Good evening. My name is Jerry Kossoff. I am an AP Stats as well as AP Calculus streamer here at Fiveable, and I'm really excited to be jumping in with statistics this evening. We're going to discuss collecting data via sampling to do surveys and potential sources of bias that can go wrong when we actually try to collect data. At the moment, as we start, there are, it doesn't look like we have anyone here quite yet. So if you're watching on a replay, I am going to wait for a couple of minutes. I've got some timestamps at the bottom for when we actually get into the different events. But of course, you can catch all the live events, all the replays by following Fiveable at Think Fiveable. You've got your Twitter accounts, Instagram, YouTube. You can find us all over the place. And so hopefully, if you do find this, it gives you some good content. I'll be going over stuff this evening. We'll talk about the purpose of surveys and sampling. There are different random sampling methods that we do need to know about for AP statistics. We'll discuss simple random samples, cluster samples, and stratified random samples are three very common types of random samples. And then we'll also discuss what can go wrong when we try to take samples. So sources of bias from bad samples, different designs that are not as good as the three that I just mentioned, a response bias, which can happen, as well as something called non-response bias. And so tonight we'll go through what do we want to do with taking surveys? What do we want to do when we take samples? How can we do it well to get what we want? And what can go wrong if we don't do it well? Okay, so three main topics. And as I mentioned, please use the timestamps along the bottom to skip back and forward if you're watching on a replay to ensure that you get what you need. And hopefully this will be a good experience for you. All right, so big, broad picture here. We're talking about statistics. The goal of many statistical studies is to take a sample from a population and use the resulting data to make inferences or make predictions about the population. So you've probably done a unit on exploring data. This is the unit that's on collecting data. How do we actually get that good stuff? And then you can analyze that data in the future by using probability rules and making inferences with confidence intervals and hypothesis tests. But just some baseline definitions so we all know what I'm talking about. A population is a set of all individuals of a certain type, whereas a sample is a group of some individuals that we select from a particular population. So this evening, we'll talk about what kinds of samples we can take from populations to hopefully collect good data and get good statistics to help represent our population. So a sample should be representative of a population. Representative means that your sample looks like the population, that it's a good picture of what's really going on with the population. So the sample chosen here looks like it's a decent representative sample of the population that it came from. Got a little bit of each type of person that's in there. And broadly, the purpose of sampling is to gather information about the population using a sample. So in your sample, you may calculate statistics like mean, median, percentages, proportions. You can use those statistics to make inferences about the population. So what percentage of all people in the United States will vote for a particular candidate in an upcoming election? Well, we'll take a sample, ask the people in our sample, and then use the results to make a prediction about the population. What's the average of something? Realize I'm blanking on a good example at the moment, but there are plenty out there. What is the average amount of TV that Americans watch in a given day? Okay, well, I could take a sample of Americans, use the data from that to make a prediction about the entire sample or entire population. Tonight we'll be talking about surveys. You've probably heard of census in the context of like the U.S. government, for example. A census, the goal is to look at all individuals in an entire population. It doesn't have to be about people. It could be about things like surveying all trees in a forest or measuring all of the bottles that go through a factory production line in an hour. That could be a census. But a survey is more talking about a sample. And so we will focus on surveys tonight, not censuses. And because samples, you're taking different individuals from the population in different ways, there's always going to be a little bit of variability or uncertainty. And so tonight we're going to talk about what can happen, and hopefully we'll get good representative samples from our population. So the broad purpose of sampling is to gather information about a population. We do that via surveys and samples, and there will always be some variability involved. We won't always get the same results if we take two separate samples, even if we ask the same question both times. Okay. So I'm going to start doing some checks for understanding. Again, if you're watching on replay, I'll have timestamps of when the question comes up as well as when the answer comes up. And feel free to hit pause, fast forward, rewind, to try to test yourself. This is better if you really take an effort to try to answer the questions as they come up, as opposed to just listening to me ramble. I can get bored of my own voice. I'm sure you might too. Hopefully you don't. But in this situation, we're going to identify the population and the sample in each situation. So the first one is that if they have a factory that produces cell phone batteries, they produce 20,000 batteries each day, and each hour, 50 batteries are removed from the end of the production line for further testing and quality control. What would the population be? What would the sample be? I'm going to wait about 20 seconds, and then I'm going to hop in with an answer. Okay, so in this situation, the 20,000 batteries every day is the entire population. And if I remove 50 at one point or each hour, those 50 batteries are the sample. And if I have another situation where, for example, Fiveable High calls 25 students from each grade level to complete a survey about the cafeteria food, the results of the survey will help influence the menu for next year. In this situation, give it about 10 seconds. In this situation, it doesn't actually give us a population size. So we can just label this population as all students at Fiveable High. And the sample is the 100 total students, because they took 25 students from each of the 4 grade levels. 100 students is the sample. The population would be all students at Fiveable High. So if you notice in these two situations, sometimes we've given a number that represents the entire population, the 20,000 batteries. Other times we can just say all students at the school, or all batteries produced would also represent the population. The sample specifically is which ones you choose. Okay, so we've gone broad, big picture, like what's the purpose of surveys? Why do we take samples? What's the goal of it? You do a lot of data analysis and inference later in the year with the samples you take. And now we're going to get into the nitty gritty of how do we actually get those samples? I'm looking at a population. How do I actually go through the process of picking individuals out for a sample or for a survey? Okay, and the first common type of sample is called a simple random sample. It's a really good way to get a representative sample by doing things randomly. Because if you randomize which individuals you take, you might get some individuals that are like this, some individuals that are like that. There should be a good mixture. So if you're trying to estimate, the height of all your classmates, if you randomly pick a few names, you should end up getting a good mixture of people. You probably won't get all the tallest kids or all the shortest kids. You should get some kind of mixed up and varied. Okay, so like I said, good mixture of individuals. And so this is our first random sampling method. A simple random sample. Every group of a certain size has an equal chance of being selected. So if I'm trying to get a sample of 50 individuals out of a population of 250, I have to come up with a method that will allow every possible combination of 50 people an equal chance of getting chosen. One of the easiest ways to do that is by giving each individual an equal chance to be chosen. Okay, and so if the task is to take a simple random sample, SRS stands for simple random sample, of 50 individuals from a population of 400, I could put all the names in a hat. So take equal size index cards, write out all 400 names, put them all in a hat, mix it up to randomize, and then pick out 50 cards without replacement. Boom, the 50 cards I have represent a simple random sample because all names were in there. Everyone had a chance to get picked. And you can imagine if I shake the hat up, all groups of 50 had an opportunity to be chosen out of those 400. Okay. If you're going to write a description like this, so if your AP problem says like describe a method that you could use to select 50 students for your sample out of a population of 400 students at school, you would have to make it explicit that the cards are equal sized or the slips of paper are equal size, and you are mixing them up. Okay, that randomness is important. It's a simple random sample after all. Okay, another method that you've probably heard of is using a random number generator. Okay, and so this is where you assign each individual a unique number. So if I have 400 individuals, I would explicitly need to use the numbers 1 through 400, or another interval. I don't know why you would pick 101 to 500, but technically you could. But I would go with 1 to 400. You also might do 001 to 400 to make sure the digits are equal lengths. Because if you're going to do a random number table where you're just looking at a list of numbers all lined up, you would need to pick like 3-digit chunks if you have a total of 400 people. And so I'm going to show you right now an example, okay, of a fully written out description. And if you've taken AP Stats or you're in the AP Stats course, hopefully you know that on the free response section of the exam, every response you give is given either an E for essentially correct, P for partially correct, or I for incomplete or incorrect. And so I want you to read this description and ask yourself, is this going to get an E, P, or I? Is this giving me a method to take a simple random sample of 50 individuals from a population out of 400? And I'm going to pause for about 30 seconds here. So if you're watching on replay, you want to get an answer, you can skip ahead. I will give a warning before I reveal it. Take a second to read this. All right, I'm coming back in about 5 seconds here. So this person wrote, assign each individual a unique number between 1 and 400. Good start. Then use a random number generator to create a list of 50 numbers. The 50 individuals whose numbers were chosen will represent our sample. That sounds really good, but believe it or not, this would only get partial credit. The reason being, when we say that we're going to create a list of 50 numbers, we have to be sure that we communicate what interval the 50 numbers could be from. Because if you just go to a random number generator, like your calculator or like a program on a computer, and just say, give me random numbers, it's going to give you, it might give you decimals, it might give you the number 6,000. And if you've only given out the numbers 1 to 400, you want the list of numbers you get to contain the numbers 1 through 400 in some combination of 50. And so you need to make a point of saying 50 unique numbers between 1 and 400 to make it clear that 50 people are going to get chosen. It might be strong to also say integer instead of number, because I guess technically you could generate the number 2.5 and then which person is it? So maybe use the word integer, but 50 unique numbers usually communicates what you need to find. So if I had said assign each individual unique number between 1 and 400, then use a random number generator to create a list of 50 unique numbers between 1 and 400, the 50 individuals chosen will represent our sample. Boom. Now I've gone from a P to an E. And so that's method number 1, simple random sample. A second method is called a cluster sample. Now, a cluster sample helps reduce some of the efficiency barriers of a simple random sample. So if you think about it, if I'm going to have to write 400 names on a slip of paper or press a button 50 times to get 50 different numbers, that's a lot. So what a cluster sample does is it divides a population up into groups, which are going to be called clusters, that are all similar to each other. So every group is similar to another group. And then you do a simple random sample of groups, get your groups, and look at all the individuals in those groups. So for a visual example, you can see on the screen here, on the top, that was like our simple random sample. Like we just, all 12 numbers are in a hat, we picked out 4 of them. But in the one on the bottom, you've noticed it's kind of sectioned off. They happen to be in pairs of 2. If we have a much larger population, it doesn't necessarily have to be in pairs. It would probably be in larger groups. Okay, but we would randomly select some of those clusters and take all individuals out of those clusters for our survey or for our sample. Okay, so in a simple random sample, we assign every individual a unique number if we're describing how to do it. In a cluster sample, you assign each group a unique number. For an in-context example, think about if you needed to get, you've been hired to survey a forest and figure out, the average width of the trees within that forest. I think it would be really time-consuming to label every single tree with a unique number and then randomly select single trees for part of a simple random sample. What you could do is, assuming that the land is relatively similar amongst all parts of the forest, like you wouldn't want a super dense area and a super not dense area, because then the groups might be different from each other. But if you divide up this forest into different plots of land, give every plot of land a number, randomly select some of those, and then go to those plots and measure all trees in those specific groups you took, boom, you've got a cluster sample. Another example could be if you, let's say you're gonna get a shipment of those batteries from earlier with the population and sample. If the batteries come in packs and they're already packaged together in groups, instead of having to open all the packs, label all the individual batteries, and take samples of individual batteries, you could take samples of the battery packs, use all the batteries in those packs for your sample or for whatever you're trying to test, whether it's, average battery life or brightness of your phone when you use them, whatever else, boom, you've got a cluster sample instead of a simple random sample. The third method that we need to know is called a stratified random sample. So simple random samples, cluster samples, kind of similar to each other, individuals versus groups. Stratified random sampling is a third method. It also involves groups, but it's helping us guarantee representation from certain groups. Okay, simple random samples and cluster samples will both naturally involve variability. There are random processes. If you think about surveying or sampling some of the students in your own class, you take a random sample of kids, you'll probably get different types of kids. And if you do that sample multiple times, you'll get different kids each time, probably. And you'll probably get different samples each time. So the results should be very variable. In a stratified random sample, we go in with a specific strategy. I like to remember this stratified strategy. In a stratified sample, we divide the population into groups, which are called strata, based on shared attributes that will impact the study. We'll talk about in a second. Then within each of those groups, a simple random sample is conducted so that some individuals are selected from all groups. So I will pick a characteristic of my individuals that I think will have an impact on the survey that I'm doing or the sample that I'm doing. And I'll make sure that I group the individuals by that way first, and then go in and take some from each. So common variables used for stratification. Sometimes age is used for stratification, like younger kids, middle-aged, like, elementary school versus middle school versus high school. If you're doing a survey of students in a school district, you want to make sure you get some from each of those grade levels. Gender is often used as a variable to stratify. Make sure we have some men, some women, people of all types. In this example that you see on your screen, we notice that color in some way. So there's the white characters, we got the black characters, got the gray characters. There's probably some characteristic about this group that the different colors represent. So they could represent different ages, they could represent different experience levels, they could represent different races. We want to separate based on that characteristic, then make sure we get some from each of those groups. The thing that's important, okay, is to tell the difference between cluster and stratified. Cluster's on the top, stratified's on the bottom. Okay, cluster samples, the groups should already be well mixed. They should be heterogeneous. So it shouldn't all be the same type of individual in each of your different clusters, because you're going to randomly select some of the clusters and use all of the individuals from that cluster. So in a cluster sample, you're probably going to be grouped for convenience. Like, it's going to be easy to get to these different groups. They should already be mixed together. In a stratified sample, we are going to create what are called homogeneous groups, groups that themselves are distinct from each other. The groups themselves are distinct, but within the groups, all the individuals have a shared characteristic. So there should be some kind of strategy in mind there. So again, as you see on the screen, at the top, there's an example of cluster samples. At the bottom, there's an example of stratified samples. I'm going to do a recap right now and then actually show you some practice problems. Okay, so at the moment, here's what we've talked about so far. Different sampling methods. All of these three are quote unquote good. They are random. We want to use randomness to help ensure a representative sample because there could be variation involved. And if we have a random representative sample from our population, boom, now I can take the results of the sample, generalize them up to the population using one of my inference procedures that we learn in the second semester of the stats courses. The three types are simple random sample, where you select individuals, no grouping at all. Cluster samples, where you select whole groups of individuals, where the groups themselves are already mixed together, so each group looks kind of similar to the other groups. And in a stratified sample, you randomly select some individuals out of each group that you've made. The groups themselves are homogeneous, meaning they look similar within the group, but the groups themselves are different. So different age levels, different experience levels, different genders, whatever stratifying variable you use should be one that you think would have an impact on the intended survey. So an example I use in my class is if we're trying to get data about cafeteria food, it might make sense to survey different age levels of kids, because perhaps younger kids have different opinions about the cafeteria food than older kids who have been at the school for a while and have more experience. And so the age of the child may have an impact on their response on the survey. That's why I would stratify by age. If you're going to come up with another variable to stratify that survey on, you would have to make a point of connecting why that variable has an impact on the response of the situation. So we're going to do some checks for understanding right now. Again, hopefully you're watching on replay. Make sure you pause. Try to do it yourself before you have the answer revealed. Okay, and I'm going to give you a few different scenarios, and you're going to identify the sampling method in each scenario. And what I'll do here is I'll actually show all three. I'll give a solid minute or so. Again, if you're watching on replay, you can skip ahead, or you can pause, or you can just try to do it real time. And then I will reveal the answers to all three at the end of that minute. So I'm going to reveal all of them right now, give you a chance to read them, give you a chance to think about them, and then I will go through the answers starting in about a minute. About 30 more seconds. I'm going to go back just a moment here. And here we go. For the first situation, Flyable High has 1,000 students, some of whom are athletes. For a physical fitness test, the athletic director selects a random sample of 10 athletes from each sports team in the school. In this situation, we have a stratified sample. The different sports teams represent the different strata. So you might have your volleyball team, your football team, your cross-country team. The athletes on those teams should be relatively similar to each other within the teams, but volleyball athletes are probably different than football athletes, are probably different than cross-country athletes. And so if the goal is to do a physical fitness test, it makes sense to make sure we have representation from each sports team. So that was the stratified sample. And the variable we stratified on was which team are you on? The second example, company creating light bulbs, ships them in packs of 20. Ooh, I might have given this one away earlier. A warehouse receives a shipment of 100 packs for a total of 2,000 bulbs. Worker labels each pack with a number from 1 to 100, then generates a list of 5 unique numbers between 1 and 100. She opens the selected packs and inspects each bulb. Because she gave the numbers to the packs of bulbs and not to the bulbs themselves individually, this is a cluster sample. In the third situation, if a principal at Flyable High gets an alphabetized list of all 12th grade students, he writes each student name on an equal size slip of paper, puts the papers in a hat, mixes them up, chooses 20 slips. There was no grouping here. We only were looking at 12th graders, so it's not like we stratified by age. It was just 12th graders that the population was. Equal size slips of paper. Every individual has a chance. Simple random sample. Again, 1 was stratified, 2 was cluster, and 3 was a simple random sample. And so hopefully at this point, you're feeling pretty good about the 3 main types of sampling methods: simple random, cluster, stratified. If you're thinking about how do I get asked about this on the AP exam, in multiple choice situations, a lot of them are just, here's the description, which of these is it? Or if I want to do this kind of sample, which of these descriptions will do it for me? So I've seen questions where they maybe ask, how do I do a stratified random sample? And they give a bunch of different descriptions. And you have to pick the one that gives, oh, there's multiple groups, and they picked some from each group based on the description. In a free response context, again, sometimes it's just, here's a description, which type is this? But more commonly, you might see situations where they ask you to actually implement the method. So that's where you want to go back and review the random number generator kind of script almost that I gave on that sample earlier that earned a P, that if you added 50 unique numbers, it would earn an E. That template for how to describe a simple random sample can be applied to any different situation where you just put in the appropriate number of the population, the appropriate number for the sample, and then the appropriate word for what the individuals are, whether it's, you know, people, students, dogs, whatever the individuals are for your sample. For stratified samples, you may be asked to justify a method for stratification. You might have just heard a cat meow. She seems very upset down here. I will give you pets later. I am on a stream. And now we are moving forward to the sources of bias. So we've looked at the purpose of surveys, the purpose of sampling, 3 good random sampling methods. And now we're going to talk about what can go wrong. And so let's start with defining what bias is. So this is us talking about bias within samples or within surveys. Remember, I know, it's very exciting, Kitty. The goal of surveys is to gather information about a population. And what if the information we gather does not reflect the truth about the population? So, there are plenty of statistics out there that you might hear about. Oh, well, that's bias. That's a biased result. That's a biased survey. What bias means in statistics is when certain outcomes are systematically favored over other outcomes. Because of variation, when we take surveys, when we do samples, we might get different results every time naturally. But if the results that we're getting are set up to lean a certain way versus another, that's when we have biased results, and we shouldn't trust any of the data that comes from those samples or from those surveys. And so one good, quote unquote, one common source of bias is when we take non-representative samples. So if we do a simple random sample, a cluster sample, or a stratified sample, we should have a representative sample. Not guaranteed, but it's pretty likely. If we take a voluntary response sample, where the only people we use for our survey are people who want to be a part of the thing that we're doing, okay, this is also called self-selected, it's probably going to lead to bias. So if you've ever taken a Twitter poll, you participated in a voluntary response sample. So you may have a lot of people responding to a Twitter poll, but the kind of people who reply to a Twitter poll are probably not representative of the entire population you want them to represent. Okay? In certain situations, that's not the worst idea in the world if the population you're targeting all has access to Twitter and all would use Twitter in a reliable way. Okay? But it's probably not the case for a lot of Twitter polls. Convenience samples. Okay? This is, by name, something that would be convenient. And what this usually looks like is taking the first blank people to arrive at X. So if you wanted to do a survey about cafeteria food, and you take the first 50 kids who come into the cafeteria for your survey, there wasn't anything random about that. And those 2 types of sampling methods will probably lead to bias, because individuals who end up in those samples probably share certain characteristics that other individuals in the population don't have. They might have, in the case of the cafeteria, the first 50 kids in line might be hungrier, might be more excited about the food, might be the closest ones there. And so there's probably something about them that differentiates them from the rest of the population that would make their sample not representative. And so if you've ever read online reviews, those are left voluntarily. What kind of person is likely to leave a review? In my experience, seeing lots of online reviews, even the ones that say certified reviewers, you're probably getting people who have really strong positive feelings or really strong negative feelings. So that average star rating, you get a lot of 5 stars or a lot of 1 stars. It's not really going to balance out in a way that shows you the true representation of what everyone who has been to that place has experienced. So it's just a sample of it, but it's probably not a representative sample. So the data you get off of those voluntary response and convenience samples probably aren't representative of the population that they should be. So I'm going to show a couple situations here. We're going to talk about how to describe the bias in that situation. It also says give a direction of the bias, and that's going to be the word either overestimate or underestimate. And I'll explain what I mean in just a second. I think you should pick it up. So if I give another one away. If I have a school cafeteria manager who asks the first 25 students in line to rate the quality of the food served, I'll give you about 20 seconds if you're watching on replay to kind of pause, think about it, skip ahead if you want to. But think about what the reason for the bias in this situation would be. What is it about those people that makes them not representative? Coming back in 3, 2, 1. Here we are. If I take the first 25 kids in line to rate the food of the quality of the food in the cafeteria, the first 25 people are probably hungry. The first 25 people are probably getting the freshest food. The first 25 people are probably more likely than others to say that they like the food. So if the goal of the survey is to get a average quality rating or a percentage of all students who feel that the food is good, we're probably going to end up overestimating what people feel using this sample, because the results from this sample would probably be stronger favorable opinions compared to what the other kids would feel. And so this would result in an overestimate of what we're trying to measure. If they were trying to measure how many of you think the food should be improved, in that case, this group of people would be more likely to say no. And so I'll probably have an underestimate of the true opinions of everyone in the population, because, you know, out of the 25 people who are the first in line, fewer of them would say yes than another sample of 25 people that I could have taken randomly. So with that in mind, second situation, if after a blowout loss, a football team puts up a Twitter poll asking fans whether or not they are satisfied with the team's performance. I know as a fan of a team that often loses, if they ask me how I'm feeling about them after they lose, I probably wouldn't feel too good. In case you're wondering, the team I root for actually is 3-0 right now. Let's go Bills. But they lose a lot, so I'm probably not going to be super happy all the time. And if you're watching this later in the year and they're actually doing well, awesome. And if you're watching this later in the year and it goes the way I think it will, I'm probably not going to feel too good. But right now, if you ask me, I'd feel really good. But if you did this situation, I would be guessing that fans would probably end up very dissatisfied. And so we'd probably underestimate the true feelings of a neutral fan in an unbiased situation. All right. So we've got non-representative samples often lead us to bias. Once we actually take our sample, we could run into other sources of bias, one of which is called response bias. There are a lot of different ways we can lead to response bias. Response bias has to do with, is the answer you're giving truly the answer that would reflect what you would feel in a neutral situation? So you could see leading questions. So this could be something like, don't you think that I'm doing a great job on this stream right now? Your opinion might be what it is, but me asking the question that way might sway you. Or if I put some information being like, when you think about all the excellent review you're getting right now for your AP stats class, whether you're reviewing for a test, reviewing for the AP exam, or just trying to do your homework, don't you think I'm doing great? I'm trying to lead you to a certain answer. So I might end up in that case overestimating how people really feel about me. Hopefully you do feel like I'm doing a good job, but maybe you'd be led to a certain answer. There could be intimidation or pressure put on. So if you had to directly respond to me in this moment about how well I'm doing, some people would be very honest. Some people would be frank. Other people would feel like, well, he's the streamer. You know, I want to tell him he's doing a good job because I want him to come back and maybe help me later. So, you know, an example I use sometimes for this is if your environmental science teacher asked you if you recycle, plenty of you do recycle. Some of you don't recycle. I'm guessing all of you that do recycle would probably say, yes, I do. And I'm willing to bet that some of you that don't recycle would lie and say, yes, I do. And so we'd end up overestimating the percentage of people who actually do recycle because of that intimidation factor that you know what you're supposed to say. This is also an example of people just straight up lying. So if you straight up lie on your answer, you're introducing response bias into the survey. An example here could be, you know, if I use the sample of patients who go to the dentist and self-report how often they floss, and use that to try to estimate how often people really do floss, I'm probably going to end up overestimating how often people in the entire population floss their teeth. Again, that's not saying people don't, but you are more likely to lie and say, I floss more to your dentist than to lie and say you floss less to your dentist. So if more people are going to lean in a certain direction, boom, that's where the bias is. I'll probably overestimate the percentage of people that actually floss or the average amount of times that people do actually floss. It reminds me I need to floss tonight. And so all of these situations are leading to bias because if you're responding in a certain way, you're misrepresenting the truth about the population. So if the real answer is that 30% of all people floss daily, if you use a sample of people at the dentist being asked by their dentist how often they floss, you'd probably end up getting, you know, more than 50% of people saying that they floss, and now we're overestimating what the true parameter, the true value of the population was. A third source of bias is called non-response. So even if I get a good sample or use a good sampling method, even if I make sure that my questions are fair and balanced and I can get good, honest answers from folks, I might end up having people selected for the sample who choose to opt out or can't be reached for some reason. And so some people might just refuse to take the phone call for the survey or refuse to participate or answer the questions that are posed to them. And so that could lead to bias if the people who opt out would have been more likely to respond a certain way than those that did. And so this is one of those things that just kind of happens in real life, and there's sometimes not much we can do about it. So sometimes we design a really good way to take a survey, we take a nice representative sample, we contact all the individuals need to contact for the survey, we ask really fair questions, and some people just don't respond. And so if you have a really high rate of non-response, you may end up getting people who do respond who end up saying different things than people who don't respond. So this isn't a situation where you didn't pick a representative sample, but it ends up acting in a similar way, where the people who actually do end up participating might say something different than the people who don't. And so this does get asked about sometimes. If you're asked to describe bias in a situation, much more often than not, the source of bias will be from a non-representative sample or from a leading question or like a situation where people might lie. So be aware that non-response exists, but it's not asked about quite as much as the other ones are. So just to recap, bias is when one response in a survey is systematically favored over another. So the results of the sample would not show the truth about the entire population. You can have bias if you have non-representative samples, voluntary or convenience samples. And the way to fix that is to make sure that we use randomization, to use one of those good sampling methods from earlier to help us avoid that bias. Response bias comes from individuals not telling the truth, whether it's using a leading question, pressure from the question asker, or people just deciding to lie in certain situations. And finally, non-response bias is when individuals opt out. And this is biased. This leads to bias if the group that opted out would have had different response than the others. And so in multiple choice contexts, I've seen a lot of just, hey, here's a description of a scenario. Which of these is an example of this type of bias? Or which type of, what situation is it? So like some of those where they do the 1, 2, 3, like which of these statements is true? And they name like, people who have access to the online polls might not be representative. Okay, that one's true. People who get contacted may not respond. Oh, that's not responsive. Okay. And so like knowing the different types comes in handy there. But in a free response context, which comes up, decently often, if you're asked about bias, describing why a sample might be biased or the result of a survey may lead to bias, you need to do 3 things. Okay. You need to identify the source of bias. So state that something is either a non-representative sample, state that this is a leading question that will lead to response bias, or state that we will have lots of non-response. Give a reason for that bias in context of the situation. I'll give an example of this in a second. And then be sure to include the direction of the bias on the thing we were trying to estimate. So if the goal was to estimate percentage of people who are satisfied with food in the cafeteria, and I do the convenience sample from earlier, first 25 kids in line. Okay, the first 25 kids in line, identify source of bias, are a convenience sample, which is not representative of the population. That's the source. The reason being, the first 25 kids in line are probably the hungriest and are more likely to say that they enjoy the food. There's the reason. Therefore, we are more likely to overestimate the percentage of all students who are satisfied with the food based on this non-representative sample. Now you've got the direction. Named what the bias was, why it was happening, and which direction it leaned, made the results lean, boom. You've got everything you need to earn an E. And so I'm going to give you a situation where a couple situations here where you're going to read them, figure out what the reason for potential bias is, and try to do those 3 things that I mentioned. This is where, if you're watching on a replay, I'm going to I'll give sample answers in a little bit and talk about like the things you would need to talk about. This would be a good idea to like try to write out an answer, try to think of what you would say, and try to compare what you did say to what I did. Unfortunately, we can't really have much interaction here, and like I would read answers in the chat and like try to give people feedback on that, but hopefully you'll be able to take something from this and compare your answer to it, and we'll get something from that. So hopefully in the future we have some folks who are live and we'll do some review sessions of this and get it going. But in the meantime, A band director instructs students to practice over the weekend. On Monday, the director randomly selects 20 band members and finds them during the school day. The director asks, how much did you practice this weekend? The results of the sample showed an average practice time of 3.25 hours. I'll wait about 30 seconds before I jump in and start going through the 3 criteria that we need to go through. About 10 more seconds here. And here we go. In this situation, the source of bias is the fact that the director himself or herself was asking the students how much they practice. And so this is probably going to lead to response bias because the people are likely to inflate the amount that they practice so as to look good in the eyes of their band director. Not saying that everyone's going to lie, but the people who are going to lie are likely to give an overestimate of how much they practice compared to actually how much they did. So my guess is the 3.25 average is probably a little bit inflated compared to where it actually was. So I was going to string this all together in a sample response. I might say something like, the band director asking students directly how much they practice probably puts some pressure on them. This will lead to response bias because they are likely to say that they practice more than they actually did. Therefore, the band director's average of 3.25 hours is likely an overestimate of the true average amount of practice time for the members of the band. Now I've got an E. Nice. Second situation. Oh, here we go. Let's see if you were paying attention earlier. A survey given to the first 100 students to enter a school cafeteria asked, do you think that the food served here should be improved, even if we'll have to charge more for it? Even if we have to charge more for it. So I'm going to give an answer in about 10 seconds. So what's really cool in this situation is there's probably actually at least two things wrong with this. And the good news is you're only asked to describe a potential source of bias. And so if you find 2 things that you might think could be a problem and could lead to biased results, pick one of them, go through the 3 criteria, and don't worry about mentioning the other because you'll have hit everything you need to hit. So the 2 sources of bias in this case, I think, so the students, that's a convenience sample, that's non-representative. The first 100 students, as we've discussed a couple times, are probably hungrier, more excited for the food, get fresher food, or some other reason that would make them enjoy the food. And so they are likely to say, no, I do not think the food served here should be improved, and we will underestimate the percentage of all people who want the food to improve. The other thing wrong with this is that is a leading question. Including the phrase, even if we'll have to charge more for it, puts the idea in people's head that now they're thinking about money. And so if we really wanted an accurate representation of who wants the food to be improved, we shouldn't mention those caveats, the things that it comes with. You should really just ask a straightforward question. Do you think the food should be improved? Asking the phrase, even if we'll have to charge more for it, again, puts that idea of money in people's heads, might sway some people who would have said yes to now say no because they don't want it to get more expensive, and we'll still end up with an underestimate. So I could say the wording of the question, even if we'll have to charge more for it, could introduce response bias because now students are worried about money and may be more likely to say no than they would have otherwise. Therefore, we will underestimate the percentage of people who want the food to be improved. Either of those 2 are equally valid sources of bias, and you'd be good to go referring to either of them and writing them out. So unless you were explicitly asked to name multiple sources of bias, which I don't think would happen in an AP context, maybe could happen in a classroom context, but in AP, not something to worry about. So today, I went through the purpose of surveys and sampling, like what's the goal of these in the first place? Let's get good representative data from a population in a sample and use that to predict things about the population. We went over 3 commonly tested random sampling methods: simple random samples, cluster samples, and stratified random samples. We should be able to both identify those types of methods as well as potentially write a way to implement at least a simple random sample, possibly a cluster sample. And then we've talked about sources of bias that can come up if we don't take nice, good samples. Like if we take voluntary or convenient samples, we could have non-representative samples. Or even if we do take good representative samples, we could end up with response bias or bias from non-response. And so use the timestamps along the bottom to go back and get extra practice with this. We will hopefully later in the semester do a couple more live sessions about this. And so we can go more into depth about a couple of these topics if I get some feedback from folks. But I appreciate you guys watching this replay. Reach out to us at ThinkFiveable if you have other suggestions for stats content we can do. And hopefully we'll get some folks on some of the live streams and get it going. Once again, my name is Jerry Kosoff. Thank you so much for listening. I'm happy to accept feedback. Thank you for your time.